So let's consider other things. How can we simulate electronic systems? And as I said, there is a component called sim electronics. This is only available on the new version of Matlab. So let's consider the operational amplifier problem. In control, we usually approximate by a linear system. So let's see how can we model such a system in simulate and what are the results. The key point here is the operational amplifier variables. This part I think you are quite familiar with it because I have demonstrated already the electrical elements. So where is the operational amplifier? So it is also with scape, SimScape. You can open SimScape here, and sorry, it should be in the foundation library. So not here. Maybe I have to check the same electronic. Not find it here. It should be somewhere in this block. I cannot actually find it myself now. I'll check that one later then. This is the model I created for it, Xue1. Operational amplifier. Well, this is the element itself. I just wonder where it is come from. I do not have enough time for it. So this is the circuit I want to simulate. And remember that there is operational amplifier. We have sine input here. And we are expecting a sine as the output signal. And you can see that the amplitude of the input signal is quite small, 0.3. So what will be the output of the system? If you check it, it should be something like this. Since this is an amplifier, it has a truncation here or saturation here, plus or minus 15 volts. It is no longer linear. And if you reduce the size of the input signal, the amplitude reduced to 0.1, then double-click this one again, and it can be seen that it is now a linear. It is a linear system for small inputs. However, for large inputs, actually the input is not quite large. 0.3 times sine t. So for a signal like this, the output may not be linear, may not be sine signals, because the operational amplifier here is non-linear. It reaches the saturation area, so it is no longer linear. So in real control, we must be very careful with those kind of behaviors in the signals. If we use it directly, it might be misleading. And for flip-flop-based M-sequence generator, wherein system identification we usually use M-sequence as the input to activate the system. and then we can measure the output and then identify the parameters in the system. Also in communication, we usually use n sequence or PRBS signal. Pseudo random binary sequence. How this kind of signal be generated? This kind of signal can be generated by flip-flops like this. So how can we create a model for it? And the question is, how can we find flip-flops? Flip-flops are provided in Simulink. It is in the Simulink extras here. And there are certain kinds of flip-flops which are usually used in electronic design. So we can use the flip-flops here. We can create a model. So this is a system we have to create, and with the system we can easily generate the PRBS signals from it. Simulation. Now change the range in the scope. 0 and then 1, 0, 1, like the sequence like this. So we can generate the sequence and then use it in system identification or other problems. And just suppose there is an electronic system, or if this part of the system in a large system, how can we simulate it? We can easily simulate it using the physical devices provided in ThinkScape. Too much. Here. Use the foundation library, and inside it, here it should be in electronics. And there are some semiconductor devices. And they can use this kind of blocks to model the original circuit. And the model is given in 3.1. So this is the model we want to fuse, and it can be seen that this model can be established easily by using blocks. We can use capacitors, resistors, and inductors, and also the NPN devices there. So we can create the system and then perform simulation, and we can visualize the final result. The result should be